Hello learners, welcome to DT 101, Digital Twin Technologies of Creating a Real World Virtually into Practical Applications. My name is Dr. Y.M. Tan, and I will be your guide to this Digital Twin Learning Journey. DT 101 is an undergraduate level course. Before taking this course, we would like you to know a little on the concepts and knowledge on Industry 4.0, sensors, Internet of Things, and computational simulation. When you are watching this video, you should have completed a pre-survey. This survey allows us to understand the general understanding of our audience so that we can improve the course. If you have not completed the pre-survey, I hope you can do it right after the video. This video serves as the first part of the second session, which summarizes the course syllabus, assessment, and grading criteria. Also, we will introduce the course instructors in the next video. In the fourth industrial revolution, the digital twin is one of the critical technologies that is gaining prominence. The digital twin is the simulation technology that integrates multidisciplinary aspects, making full use of a physical asset, real-time sensory streams, and operational history. During the course, you will engage in the concept of creating digital twins and utilize them to model, simulate, and manage industrial process. Digital twins give information into every component of your engineering process, allow you to improve the efficiency and efficacy of your operations, production, deployment, and maintenance. The digital twin is used to monitor, predict, and analyze physical assets like buildings, process, and systems in industrial, social, and economic fields of application. The course is comprised of a total of 8 sessions, including a pre-survey, 5 modules, and a post-course survey. The module theme includes the feature Introduction to Digital Twin, Manufacturing and Production, Supply Chain and Warehousing, and Healthcare. Each themed module may include an introductory video, lecture videos, case studies, software demonstrations, forums, supplementary videos and resources, and a module test. There are in total 32 lecture videos, and each lecture video is between 4 to 6 minutes in length. Session 3, namely What is a Digital Twin, includes 6 videos and a discussion forum. The subject begins by defining the digital twin and outlining its primary qualities in the modern research and industry centers. In addition, we will highlight 13 innovative technologies influencing digital twin, their applications, career prospects, investment opportunities, research opportunities, and skill sets, as well as security, risk, legal dependability, and uncertainty challenges.
Section 4, namely Manufacturing and Production, contains a total 10 tasks, including 7 videos, supplementary reading, a discussion forum, and a test. In this session, we will begin with an introduction to digital twin manufacturing and production, and its characteristics and technological elements. We will also discuss the impact of cyber-physical systems on the manufacturing ecosystem, the power of process automation and optimization, the demand for predictive maintenance and anomaly detection, the management of manufacturing assets and processes, the design and simulation of production lines, and the production diagnosis and maintenance. There are case studies on the application of servo motor to the digital robotic chains and 3D printing.
Section 5, namely Supply Chain and Warehousing, contains a total of 9 parts, including 6 videos, 1 reading, 1 forum, and 1 module test. The module begins by introducing the supply chain and warehousing with a digital twin, digital twin-based operations and management, and simulation-based smart supply chain ecosystem. In addition to the smart supply chain in the pharmaceuticals business, additional examples include quality assurance in the food and beverage industry, warehousing with machine learning and path planning problems, and warehousing with machine learning and pallet loading problem. There are case studies, such as the applications of mixed reality in warehouse management, and it can be based on blockchain technology.
Session 6, namely Healthcare, contains a total of 10 parts, with 7 videos, 1 reading, 1 forum, and 1 module test. In this session, we begin by addressing the healthcare and bioengineering applications of digital twins. Digital twin-driven healthcare industry and its potential industrial-scale biomanufacturing, hospital management in Industry 4.0, pandemic control prediction, and cloud computing for radiotherapy systems are among the subjects covered. There are case studies recording the applications of virtual reality in bioengineering, 3D printing, and blockchain-enabled healthcare administrations. In the end, there will be a module test. Session 7 concludes the course with a total of 6 parts, 4 videos, 1 FAQ, and 1 final test. The final module ends the entire course and provides a digital twin future forecast. There are discussions on the fundamental characteristics and application of digital twin, the future of digital twins, a forecast for Industry 5.0, and concerns regarding the digital thread and digital shadow. We will ask the learners to complete a post-course survey in the last session.
There will be an entrance test at the beginning of the course to determine how well you are prepared for it. On the entrance test, there will be no grading of any kind. The entrance test serves as a benchmark on how well learners comprehend the digital twin, and it will also allow our team to compare the knowledge of you have gained after taking the course. The entrance test and the final test are automatically graded, and exercise including multiple choice, true or false, and fill-in-the-blank approach.
At the end of each module, there will be a peer open response exercise for learners to express their opinions on certain topics mentioned in the module. Learners are allowed to express their own perspectives, share their opinions, make observations, and ask questions on themes or questions brought up in the class and readings through the use of an evaluations called open response questions. Learners are also allowed to discuss and express their opinions based on each other's input through our ethics discussions platforms. In the end, learners are allowed to grade each other's as part of the learning outcomes.
Tests covering the topics and information covered in each module are given at the end of the 2nd to 4th modules as part of the portrait test. In addition, there will be a final test at the end that covers the overall material and knowledge covered in the course. There will be a variety of questions formats on the test, including true or false, multiple choice, fill-in-the-blank, and short answer questions. In each test, there will be no more than 20 questions in total. The 3 module tests account for a total of 60% of the final grade, with each test accounting for 20% of the total. The value of the final test contributes 40% to the overall grade. The grading range for the entirety of the course is maintained at the same levels as in pass or fail, with a threshold of 50%. Anyone who completes the course and earns a grade that is higher than the minimum required to pass will be awarded a completion certificate.